And I would like you, as I told you, to have a class where you are able to speak, I mean, to discuss freely. So whenever you have something to say,
Uh,
just ask.
may I have a question,
Yes.
please? Will the courses materials be available somewhere, or should we take notes?
No, they will be available. But as in the last years, I wrote in the last years, I was writing quite a lot on the blackboard in class. So whenever I do that, try to write the same thing or try to do the same figures and representations that I do, because those are not generally available. I don't have them. I actually produce them there.
Okay, okay, thank you.
So we will use the whiteboard instead of the blackboard right now. I'll try to share it with you. And you know what? For the drawings, I can even share those with you whenever we are done with some parts of the figures that I'm going to represent. I will share them with you as well. But sometimes they get quite messy by the end because I do a lot of examples on them, and sometimes it's not that clean. I'll try to make it a little bit cleaner than in class, but as we solve some problems, I go back and then I show you something, and everything stays written on the on the whiteboard, and by the end it might not be that that nice. There was somebody that was asking control, I think by mistake. Um, I would give you control if you need it when I'm drawing things on the blackboard. But as I told you, feel free. We are 126 already.
May I ask also a question?
Yes, go ahead.
Is it possible to have the materials for future lectures before it actually starts?
I think yes. In case I can put it in the, I mean, they are already available into the web page. We will get to that. And with this in mind, as this part of the first class will be part of it, administrative things, and we will start delving uh, into network programming just after that. And so that you are able to start your first lab, and then we will continue on in the next lectures. So, as I told you, administrative things. We will have weekly lectures. Unfortunately, at 8 o'clock in the morning. I know I kind of have the same opinion that you have. It's a little bit easier now because we don't have to go to school. Sometimes I missed, I don't know, 20 minutes of the first hour because with the rush hour in the morning, I wasn't able to get to the university in time. Sometimes I get from home, I start from home at 7:20 and I'm there at 7:40, and sometimes I start at 7:20 and I'm there at 8:15 or something like that. So it's kind of difficult sometimes. Presence is not mandatory during the lectures. I know I'm not recording this, but I'm telling you it's not mandatory. If there are some of you that are already familiar with the notions that I am presenting here, and you can feel that you can sustain an examination at this class without being there in the class, I mean, for the lectures I'm meaning, then I won't take any presence during the lectures. On the other side, labs are mandatory, and I need to actually provide some situations of your presence during the labs. So there we cannot skip. We need to talk whenever you cannot be there. And you have the right, I think, to miss 2 labs. I think you already know that. And more than 2 labs, we need to arrange somehow, because otherwise, when I will transfer those statistical part of the presence, in fact, it will come out with the fact that if you miss more than 2 classes, you're not allowed to go to the examination, and if you're not allowed to go to the examination, then practically even if you come and you get a mark, you'll miss the examination. But these are not my rules. I think we will manage as we did with all previous years. Now, for the lab, and if I take my tools here, for the lab, for the lab, you do not have any individual assignments. It's a special kind of lab. I'm not sure you had this before. In fact, you'll have a set of problems, and we will deal with them theoretically. I'll show you some examples, and then you will need to be able to solve out of those problems as many as possible. I will be there with you. I mean, we will be there with you, with all the guys that are doing the labs, and you won't need to schedule any appointment for giving in those problems. But instead, after a few weeks of labs, we have two sections. We have one programming section in the first part of the semester, programming computer networks, or communicating applications, and then we'll have a second part where we will, I really need to eliminate this each time because I'm hearing myself on the recordings and it's not nice at all. And we will have a second part where we will be playing with a simulator, with a network simulator that allows us to represent at least at the given scale about any network with all equipment that we can have in a network, with communication between different networks and the different technologies that are involved there. And that part will be dealing with IP, TCP/IP communication protocol, and how it's deployed and working over a network. These are the two parts that we need to deal with. And after each part, you'll have a sort of test. Okay, so by the middle of the semester somewhere, you'll have a first test from the programming part. And by the end of the semester, you'll have another examination from the simulation part. You need to pass both of them. And the final grade will be, for the lab, you'll have the average of the two tests, provided that both are passing. You take both passing marks, passing grade. And there will be a final written examination or Moodle test. It will be a Moodle test on this semester. And this will be in the examination session here. It won't be in the... It's not by the end of the semester. It's... It will be session in the examination session. This. Okay. Are there any questions about this?
Can you see when someone raises their hand? Because there's a hand raised.
Yeah, I see one. I just wanted to finish, so just feel free, okay? Whenever you just ask, whenever. I think it's more important to have a dialogue. We will see. If the things are getting messy, then we will try to do differently, but I would rather prefer that you ask. I don't mind stopping from what I'm saying from time to time, or if I don't stop right away, I'll tell you just to waive a little bit your question and I will come back to you. So, Dan, you can go ahead and ask if that was not a test.
I think he forgot to lower his hand before.
Sorry?
I
Yeah.
think he asked a question and forgot to lower the hand.
Yeah, probably. It's done. It's not there anymore. You went away. Back. Okay. So, 2 tests, 1 model session in the examination part for the exam in the session that will combine take your final grade by averaging them. What do you need? What do you need to know for this class? I mean, to be able to manage throughout this class, you would need at least some C, C++ system programming that you already did during operating systems class. Some notions of operating systems, Unix and Windows mostly, and Linux and Windows mostly. And because it's easier to actually work in Python, and forget about this one. I would not use this one. If I were you, but if you want to work in PHP or some other interesting language, you are free to actually solve those problems in any programming language and programming environment you want. But Python, that will be a thing that I would rather prefer you use. I know that you have some classes, you had some classes before in first year for Python programming. It's easier to actually implement things fast where you don't pay that much attention to the environment, but you're focusing on your problem that you're trying to solve. And for that thing, it's quite appropriate and it's good. It's something that it's made for that. Why do I need C and C++ programming? Because there are some things that you won't be able to understand that easily while working in Python on some not strongly basis of computer networks. And of course, what I would like you to do, because we have this approach where I'm teaching you the basis of computer networks, is that whenever you have a problem or if you're interested into something related to computer networks, or to the other stuff we are going to talk around the lectures, feel free to bring that problem into the class and feel free to discuss it with us. Let's discuss those in the class and handle them. Now, about the materials that you all need to go over in order to get the theoretical part into this class from this class. We have this first book, which is written in bold, James Kuros, K. Ross, Computer Networking, a Top-Down Approach. Now, this is the book where you can actually take all the theoretical parts that we are going to study during this semester. There are 4, at least to my knowledge, revisions of this book. Maybe there is a 5th one or 6th one right now, because it's quite old. And this is the book that you will need to actually go over the chapters that are actually that we are going to actually study. It's quite a large book. I mean, it's quite thick. I have it here physically. I'm looking at it in the library right now. It has something like 5 centimeters if you want the physical measurements, width or depth. But you don't need to go over the entire book. There are only a number of selected chapters that you need to go over. But this is the capital book, I mean the principal book that you need to have. I will provide it to you in electronic format. And I have it in paper format, but I only have two of them. So if you need it in paper format, I can lend them to you. But there are only 2 of them. The second one, it's again a book, Tannenbaum. It's an author that is well known in operating system and computer networks. he has a number of books and materials around these topics. This one, it's even thicker, I think, as a book. It's once again in physical measurements. But we won't get into that many details from Tannenbaum because it goes very deep into the lower parts of computer networking, dealing with a lot of signaling and electronical things that are happening when signals are moving through the cables, through the ether, and so on. So I feel that the first book, it better covers what we are trying to study. So those two are the things to, I mean, the first one is the one you definitely need. The second one, you just need to take a grasp from time to time. And then you have this one written in bold, Volume 3, Client-Server Programming and Applications. This one actually provides you some information about programming, the first part of the lab, programming sockets and computer networks. So whenever there is some parts that we are not covering and you feel I don't cover enough in class, and if you don't ask me, you don't, even if you ask me, you don't get it right away how it should or how you should, then this is the book you need to go over. And then there are a number of others that, of course, you can use. The last one, the sixth one, Unix Network Programming, Volume 1, the Sockets Networking API. It's a quite old one, and it's online. I think it's available freely, but it's a quite old one, and not that things have evolved that much in network programming, but operating systems have changed slightly the way they approach those APIs. So not sure if you need it. You definitely need the first one and the third subpoint too, those two. Okay, I will provide them here or as links into the team. Now, about the class information. This is the web page where I will try to leave everything for you. But now, as we have the Teams, team, Microsoft Teams team, we will exchange a lot here. And show you what do we have here. It's something that looks like this. So if you see it, it's something like this. It looks like this. And you have here the persons that are persons that are in charge with the labs. I have my email address, but I would rather prefer now to have discussions on Teams. If you can, just write me on Teams, because on Teams I have it always on my phone. So whenever I am available, I will be able to answer you. If it's something personal, just write me directly, a personal message. If it's something that it's addressable to more than one person, then just ask it in the general group. You have the code for joining the team if there is anyone that hasn't joined the team. How many of you are in the class this year, second year English?
We are about 200.
200. You weren't a little bit more in the first year? You started 200 or you got down to?
I don't know exactly. I know we started 200. I haven't checked exactly this year how many, but I will.
Ramona, it's Ramona who was talking. Ramona has already helped me a lot, so I see she started right from the beginning on with the right foot. Okay, thank you. So you have here also, I'm not sure, tell me if you prefer to have it this way. This way it's public into the web page, but when you click that thing, rate, to get into a web page where you have each group, just check if you are assigned to the correct group there. And you'll have the presence marked here during the labs, and then you'll have the grades or marks for the socket part, for the programming part, and for the packet tracer part and the final lab average. This way, everything will be transparent. Whenever you get a mark, you can see it right away there, before it's published to Academic Info or whatever other official, application for handling your grades. If you feel uncomfortable with this, I can unpublish this document from here, from the web page, and I can publish it into the Teams part, and you can look it there. There will be a link that will be published there, and you open it from there, so that not everyone accessing the class will be able, the page will be able to see what is happening. Just let me know eventually, not right now by speaking, but by leaving me messages or things like that. For things like that, in the future, we will do polls, because I think it will be easier to actually count what is happening. Just note that this is the web page where you have the online lectures. Pay attention, because you already asked me. You have the lectures here. Just pay attention that with all materials, attached materials, like you have a folder at each time, and you have some examples together with them and things where we can discuss over. Just pay attention. I will try to reorganize them, because we are not actually attacking them into the order they are here. We will do lecture 1, lecture 2, 3, and then we will skip at somewhere 6, 7, 8, 9, and then we will go back to physical data link layers and all the stuff which is not that important from my point of view, and we will get over them a little bit faster and by the end.
May I have a question, please?
Yes.
I looked at grades file and I look at my group and I don't find myself there. Like in 9026.
Yeah.
9026, yeah. I'm Gokhandan. I don't find myself there.
Okay, I'll try to import the users again. Yeah, all right.
Okay.
Did you move from one group to another?
I froze my year last year and I restarted my studies this year.
Okay, so you're actually moving from the last year's class. I mean, the last year of study to this one. So that's why. Okay, 926. Just give me your name. It will be easiest.
Gokhandan Catalin.
Right now, but this one, I mean, you can ask them. Do you know your login?
GDIE 2535.
And actually, you're 936 now.
Okay, thank you.
Are you in the third year, or you just froze and you're
second year? Second
okay,
year, yeah.
Okay.
Second year.
I also wanted to address this, but I thought I would write a private message. I am a third year student. I went with Erasmus last year, so that's why I'm taking this class now.
Okay, but you haven't had any chance to...
No, I couldn't. I didn't find any course where I went. No matching class, and I didn't have the chance to study for it and take it when I came back. So I'm taking the class now.
Okay. I'll just write me a message and I'll put you into. Just let me give me a private message and I'll put you in whatever group you want.
Okay, thank you.
Okay. So about this. This is about the web page. I'll put it down. Start again the presentation. What are the required tools, materials that we will need in class? Well, in order for the first part of the semester, you'll need a Windows 32/64, doesn't matter, bit operating system, either as a physical machine or as a virtual machine, and a Linux system. Why both of them? Because I want you to be able to notice there are slight programming differences between, when dealing with network, there are slight programming differences between the two platforms. Not radical, but there are some. And you need
I
yeah?
have a question. If I have Ubuntu as a main system, should I install in VirtualBox what version of Windows? 7, 8? I think 10 is a little
overhead, a little more, too much overhead. It doesn't take that many resources. I mean, you can install Windows 7, that will be enough for sure. I mean, things have not changed into networking, at least not on the basic things that we are doing.
So Windows 7 should be okay?
Windows 7 should be okay. Just pay attention that it will nag you with the updates, and if it tries to start that online update, it will take forever if you don't have the virtual machine.
I know.
So that's for your own experience with it. I know I have a few virtual machines with Windows 7, and right now it's a pain to use them because they always try to go and check for updates. And
I usually enter in the registry editor and erase all the.
Okay, that's fine. If you manage it, just that was the notice for you, so that you know how to deal. If you know how to deal with it, that's fine. Now,
Okay.
as virtualization platforms, VMware Player, VirtualBox, VMware Workstation. VMware Player and VirtualBox are free. You can use whichever you want. VMware Workstation, it's a paid application. It's a little bit better than both of the other ones. I won't teach you how to, if you want to use that one, I have that one. But as it's paid application, I cannot provide it to you. And I won't teach you how to get hands on it, but I'm pretty sure you can manage if you want to get hold of a working copy of that. So I won't enter into too many details here. What else? Install Linux, Windows, whatever you don't have. The thing that I do want you to do is this one. Whenever you install whatever operating system you install the integration tools or VMware tools or VirtualBox integration tools into the guest operating system, so that you have normal experience with it, not a small window centered somewhere in the center of the screen where it will be kind of difficult to actually do any sort of programming, because it will be difficult if you don't do that. And again, this point, I am actually fond of it. Do install a development environment. My last year's experience with after you took the operating system class was that you actually did all your or most of your labs in this tool here, or in Joe or in Pico or whatever. And while they are good editors, especially VI, it's a very powerful one. We don't know how to use, I mean, maybe you know, but I don't know. I know there are a lot of functionalities. This editor is so powerful that it could be the backend for any graphical user interface editor that we have today. Only that it has so many things inside that it's kind of complex, and the learning curve is so high that except basic things, few people use it. So install a development environment. PyCharm, if you feel free with it, if you feel okay with it, install latest Visual Studio Code. It's a quite good development environment. You can configure it to program C, C++, Python, whatever you like, and it works on both Windows and Linux, and I think macOS as well, because it's an Electron application. Actually, it's a web app packaged inside some binary shell. What time is it? 55. And use a development environment. Why? Because you'll have problems where you need to debug, and I would like you to be able to debug your code and take a look at the values of the various location in memories at different points during the runtime of your application. And I want you to be able to inspect those things, and unless you're a master of a debug tool, command line debug tool on Linux and on Windows, which are not that easy to use, it will be better to actually use a development environment. Now, if you have any preferences on this, as I told you, I would consider, on Windows Visual Studio or Visual Studio Code. PyCharm. Do you know any other things that you would use? There is Qt Studio for C++, C++.
I guess CLion also works for code blocks.
Yeah, code blocks. And yes, you can use those one as well. There's code blocks. I'm not sure they still keep the Windows part working as well. They do work. This one works both on Linux and
I still have code blocks, so.
Yeah, they have it. I'm not sure they still maintain both Windows and Linux branches, and I'm pretty sure it doesn't work on Mac. If you want something that works on, just so that you're familiar with what is what you're doing, Visual Studio Code I think works on all three platforms. If you have a Mac OS, forget about Linux. You can program directly there. Okay, if you have a Mac OS that's 99% compatible with Linux, and it's from the computer network's point of view, when programming, it's about the same thing.
Can I ask something?
Yeah.
How often will we be switching between operating systems? Because I have dual boot, so Linux and Windows.
That's not an option
because
suitable? Yeah, no. Well, it's not really an option, because what I want you to do is to develop you'll be developing client-server application where you have client running on one platform and the server running on a different platform. And I want you to see what is happening when you exchange with an application, for example, written in Python on Linux with one written in C++ on Windows.
Okay, and if we have a separate machine like a Raspberry Pi, would that be suitable to SSH into it and work on that?
Yeah, that will be suitable if you don't have a powerful enough laptop, but compiling small chunks of code on what Raspberry Pi do you have? 4 version?
Yeah.
Okay, maybe that will do it. I don't have one to see how it moves, how it behaves in a graphical user interface, but if you feel it's okay for you to program on that, well, feel free to use it. There is no problem. I don't have any, as long as you have those operating systems available in parallel, I don't have any issues. These things are not mandatory. It will just make things easier for you.
Okay, thank you.
Okay, now this part, I think, not sure if we can forget about it. Whenever you install the operating system, set networking to bridged was something that I was asking in the last years, and it was something that I was telling you, you'll thank me later, is because whenever you set the networking of the virtual machine into bridge mode, in fact, you are integrating the virtual machine inside your local area network. So it goes into the same network where your host machine is situated, so you're able to actually communicate easier between the two machines. It's more easy to communicate between the two machines. And with this in mind, I have here, I don't have neither VirtualBox because for me it's not fast enough. It's slower than, usually it's slower than VMware. So I prefer virtual VMware Player and VMware Workstation. I have a number of virtual machines. What I suggest you to do, I think you had that. I have enough RAM. I have an Ubuntu. I have an Ubuntu 20.04 virtual machine for the Linux machine, to which I assigned 8 GB of memory. Now, on your machine, pay attention when you create those things to actually not use all of your physical RAM on your Windows computer. Try to assign half of it or 75% of it at most, not more than that. Leave at least 2 to 3 GB for Windows 10 if you have Windows 10. If you can, more, because otherwise things will start to move very slowly for you and the experience will be good enough. I have 32 GB of RAM on this machine, so I don't really care about how much I spend into the virtual machine. Whenever you create the hard drives for your virtual operating system, try to, I have the option, but try to create them with thin allocation. You'll see, whenever you create a VM, let me show that to you. Not sure, I create a new one, install the operating system later. Number of processors, I don't care. Wow. Bridge that's working. Okay, go on. Creating a virtual hard disk. Try to do this like this whenever you have these questions. Store virtual disk in a single file. If you're on a Windows operating system, that won't do any damage. I mean, it tells you to split into multiple files because they are easier to handle. But if you misplace one of them or something happens to one of them, then your entire virtual machine is corrupt. And don't click on this. Allocate disk space now. I can actually put here 1 terabyte of data. 1,000 gigabytes, even if I don't have that physical space, if I don't click on this one. And the virtual machine will use as much disk space as needed for the already allocated data. And its file will grow as you use data. So you'll find yourself that you can actually put a 40 gigabyte disk, and you'll see that on your hard drive, on your SSD, it will only take 1 gigabyte or 2 gigabytes or 3 or 4, depending on the operating system that you're installing. And I'll cancel here. Okay, and by the end of this class, in a few minutes, I think we discussed everything about the administrative part, and we will start to actually talk about what's related to our class. And I'll leave a few minutes for other questions. If you have installed correctly your virtual machine, you should have something like this. Not the black screen, but you should just wait. You should have something like this. And if I do this, virtual VMware, if I do this, the guest operating system should resize at whatever size I do that. If you do that correctly, you will be able to actually, not this one, I'm going here, you will be able to actually take a file and normally. Bring it into your host directly, so you'll be able to do that. It does this from time to time, but normally it's working. So you can take a file from inside the virtual machine, and you can actually either copy it and paste it on your host, or just drag it between your host and your virtual machine. So it makes things for you a lot more easier to work with. Now we'll need to wait until it figures out that it's not doing something. I will wait. Do not report anything. It has frozen quite. Let's do that. Let me see if I can display it. Now, so this was about the. I'll restart it. I'll restart it in the break, during the break. This was about the administrative things. Now, if you have any questions about this part, how will we be tackling classes, how labs, things like that, well, we can discuss them now in the remaining minutes. We have 4 minutes to the break, or we'll take a break.
Sorry, I have a question.
Don't be sorry.
Do we need
to have a question?
Do we need a development environment on both machines?
Unless you're a master of installing cross-compilers, so that you're able to cross-compile the source code from one operating system or from one platform to the other, I would say yes.
But we don't need for Python to.
For Python,
right?
you don't need. Yeah, for Python, you can just. But what happens if you want to debug the server which runs on the Linux platforms, and you only have some glitches there and not on the other platform? I would say, I mean, it doesn't take that much space to put in Visual Studio Code. Visual Studio Code, its only drawback is that it's a little slow if you don't have a powerful enough computer. But for whatever computer, mine, this one is from 2015, and I don't have any problems to run some of those things on it. So I would say yes. It will be better for you. But if you think if you can manage that, yeah.
I also wanted to ask, why did you cross the bridge thing on the presentation?
Because it's not mandatory. What we did.
Oh, okay.
Okay, what these things does, I can explain that to you. I can explain that to you quite fast. Let me just erase what we have here. Clear. Okay. So what is happening when you set that into bridge mode? Well, I'll show it somewhere here. When you have a network at home, where you have your host, and your host is here. And I'll put it like this, and then you're connected to the internet with a router. There is the internet. Your host, suppose it's a Windows machine, and then if you set the networking for the virtual machine as bridged, actually it will appear to be here into the same network as you, in the end, and it will connect to internet exactly as your host, and it appears that you have two machines into your local area network where you might already have some other machines as well, like you're at home. As opposed to setting that to NAT, and in the NAT case, the same network, while you have your host here, And what it's doing is that it creates a different network here, and your VM it will be stored here. So other machines from here will not be that easily connectable from this network. You'll need to deal with two different networks. We will see what that means. That basically means that here you have a different set of IPs. You won't have the same kind of IPs as into this. You would have here, for example, 192.168.0.0 something, or .x, sorry. And probably you'll have here something like 192.168.100.x. Okay, and this part tells me that here the fact that these things are different makes a little bit more difficult. If you don't know how to do that, it won't make communication between your virtual machines as easy as it should be when it's in bridge mode. More than that, when we were in the campus, everyone into the same, all of your hosts were here, and having all your virtual machines as well into the same network will allow you to actually, what I did last year was that I asked guys in the same group to actually write separate parts. One of you was writing the client, the other one was writing the server, and then make them communicate with each other. I will see if I can figure out a method to enable you to do that this semester. I know some ways to do that. I'm not sure I can transfer that to you without some consequent part of configuration, so that you're able to access each other's networks, each other's networks easily, without spending 2 hours configuring things. So with this in mind, do you have any other questions, or you take the break? We're already into the break. Perfect. I think so. No. Sometimes here, when I'm here, I only see Corina online. Sometimes I'm asking myself, are they playing Fortnite or whatever?
God forgive them.
Or they are here with me. So whenever you feel I should move faster, whenever you feel, okay, we know that, let's go faster, just tell me, and I don't need to cover all the parts that you're already familiar with. Okay, let's take the break, and I'll see you back in 10 minutes or something like that, okay? And feedback, it's important for me. If you answer in written or in voice, just do it.
Is the break like 10 minutes or?
Yeah, let's take a 10 minutes break, okay? Okay, I'll see you back in 10 minutes.
See ya.
See ya. So this is my, for those that are already back, I'm back. Let me just. Okay. So, are you back? Are you? Everyone is here. Just leave me.
Yes. Yeah.
Okay. So my idea about what is happening in reality with these online classes is this. You see it projected right now.
Smart kid.
Yeah, and in fact, he's playing. So if I don't have any feedback, you know, if we don't discuss something, so we can discuss something for 10 minutes, not related to computer networks, if you would like that. If you would like, I think it would even be good for us to, you know, develop some sort of relation, because we are not robots and we're not here just for me teaching and you staying there and listening. So we need to develop some kind of relation to be able to understand each other and why we are doing things the way we're doing things, so on. Let's skip this. So, and this is the first part, so only for 5 minutes. The things we are going to study. What I see here on my screen. And I don't like that I'm sitting all classes. Usually I was standing and I was doing a lot of hand movement and explaining things, stuff. But right now I'm just moving a pen and mouse, and that's the only 2 things that I'm moving, and I'm not feeling very comfortable with it. So we are going to study this semester programming at the beginning. And activate thing, laser. TCP/IP. We are going to study TCP sockets, UDP sockets, then we are going to go into the theory of computer communication, like communication protocols and hierarchies, the standardization models around the TCP/IP, and then we will delve into the IP protocol. This is the part that we are going to study about computer networks, the TCP/IP protocol, and we will go into quite a few details about it. IP addressing. This is one part that I would like this part to be something that stays on with you. If you stay after this class with this part here, if you understand everything about IP addresses, how do we assign them, how do they work, how packets or how data is traveling between the computers, by using IP addressing schema plus routing, the different part that we are going to study. If you understand a little bit of this, which enables us to actually translate machine names to IP addresses and vice versa, and get references to services and so on. And if you understand, routing was already here. This part, I would be plus this thing. I think you are going to pass this class with a maximum grade. Of course, you also need for the examination part the communication protocols, the whatever other stuff. But if you understand, and if you are practically, if you are going out of this class, understanding how to program a networking application, how IP addressing, routing, data exchanging is going, and what TCP and UDP are and how they're, why there are 2 of them and so on, I am myself satisfied, and I know that you'll be able to tackle you'll be able to start any project, you'll be involved at any company related to networking, even though you might need to study some stuff, you know, to go deeper into some of the stuff later on. But if these parts are covered and you know them, then that's what I'm interested in. Okay, and with this in mind, this is a part that we are going to skip right now. I will be getting back to it later on. I would like us to start discussing about this. the client server. We are going to start with a programming part of computer networking, and the most used paradigm when dealing with this is the client server paradigm. That means most of your application will be developed in the client server approach. Now, I'm pretty sure that you studied this during operating system. I mean, you talked about it. Can somebody tell me what the client server paradigm or approach means in reality? Because it goes down to one thing or two things. The most important thing is?
So you have more clients than servers. You have a few servers. For example, if you have a local network, you need only one server to communicate with other clients, and it would be easier to have one server and many clients, because if you have an app, you can centralize all the data in the server, and the server gives it from one client to another. I tried to develop last year an app on my own with client-server relation, but my laptop broke and my data was lost, and now I didn't want to begin from start.
Okay, thank you. Yes, that as well. But the most important thing in client-server paradigm is that we have two entities, the client and the server. Usually the server implements what is called the main business or application logic. And the clients connect to the server, interact with the server in some ways. In our approach from the networking point of view, they connect to the server, they ask for some service, and they get back, the server resolves that request that the client is asking, and then it answers back to the client. That's why it's called client server, because we have an asking party and a solving party which resolves the problem and sends back to the client some result. This is the way most of networking applications are implemented, with only one difference. Did you implement any client-server application during operating systems when you worked with, how can I say, pipes?
Nope.
Nope.
No.
You didn't talk about it at all, or?
We talked about file I/O and why we have to optimize our code. So when we are getting data from a server, we have to optimize our code, but we didn't do it in practice.
Okay. Now additional questions, because I'm not sure. I'm sure I didn't ask it, but it changes from year to year in operating systems. Did you had any socket programming or not at all?
Not at all.
Not at all. So, okay. We'll need to take it from the beginning. Okay. Okay then. Basically, when you implemented, I think most of your unnamed piped applications in operating systems, or named pipes applications in operating systems, you actually used this client-server paradigm. You had one parent process that launched in unnamed pipes approach a number of children processes, and then it communicated with them using pipes. Now, the server would be, in that case, either the parent or the child, depending on how you implemented the problem that you were given in hand. But basically, you use the client. Normally, you use the client-server approach. You send something to the server, and the server you send two numbers, and the server did the sum, computed the sum of them, and it returned back a result, something like that. Okay, so this is the basic approach that most of networking applications are dealing with. Okay, there is a request or reply, whatever I explained to you. Usually it involves at least 2 processes. Okay, and I'll try to go a little bit fast over this because it's mostly descriptive and it only gives you a general idea what is happening. It's not getting into too many details here. So just tell me if I need to go back and explain some parts of the slide which I'm skipping. Otherwise, I will go a little bit faster. And don't feel shy. I can stay. We can stay. I'm planned with this class. I'm planned. I know how to cover the class. I can cover all the stuff if you're not able to watch it, or I can skip parts as well, and we will get into more advanced things. Also, I've seen some questions in the chat. Feel free to ask them. If you see that I'm not answering a question that you're asking there, is because I'm looking at the slides or I'm looking. I don't have that many real estate on. I have 2 screens here, and I feel like I will need 3 of them in order to be able to actually cover all the things that I need. So if I don't answer one of your questions, just pop it out. Hopefully, yeah. Okay, we will discuss about Wi-Fi's, why they are disconnecting, and why they are working like they are working in a class. If you want, I think we can even, not even in a simulation, maybe we can do that on a live, exactly with an access point and some clients, and show you what is happening. I would like to do with you things that are interesting for you. Because I know I am able to cover all my theoretical aspects, but meanwhile, if I can actually touch some parts that are interesting to you, that's even better. Okay, so feel free to ask if you're interested about anything. Maybe I won't be able to cover it right on the spot, but I will prepare it for the next time, or for in 2 lectures or something like that. I will prepare something like that. Because for the access point, in order to show you something, I need to set up an environment to be able to show it to you. Okay, so basically what is happening when dealing with networking is that usually we have 2 machines that are interconnected by some sort of network connection. It could be wireless, it could be cable, an electrical cable, it could be fiber optics, it could be any transmission medium, it could be fire and smoke, whatever you like, for that reason. Okay, on those hosts we have 2 processes, one on one host, one on the other, that are trying to communicate with each other. And that is happening when we are talking about networking through a socket. That's the principal, the TCP/IP socket. That's the primitive that you are going to use. It's the only one available that enables you, like pipes, to communicate between processes on the same computer, while sockets are primitives that allows you to communicate between processes running on different computers if they are connected by some network. Now, behind the socket, we have some sort of communication protocol. In our case, will be TCP/IP, which contains 2 protocols, TCP and UDP. We will see the differences between the 2 of them, that are implemented usually inside the operating system, and then they are traversing data through internet or through a local area network to the other machine, and the communication is happening this way. How? Well, from the programming point of view, we have an API, which is a set of functions or methods that we call at the operating system layer, that allows us to actually create the socket and use it for communication. Now, and I have some questions for you here. For a process to receive messages, it must have some identification. Some identification or some identifier. Do you know from your own experience what is used in TCP/IP in order to identify a process, a machine? I'm pretty sure you've heard about it.
A MAC address?
Amongst other, yes, but it's not the most important. I mean, it's important, but it's not the definitive one. The one identifier that we are working it every day. When I connect
the IP address.
IP address.
The IP address, exactly. Each machine connected to a network needs at least one. Identifier, an IP address, which on IPv4, that's the protocol, communication protocol we are going to use. There is an IPv6 version of the communication protocol. It's not that they are, I mean, yes, they are evolving versions, but and they are cohabitating nowadays. They are both IPv6 and IPv4 working. Come on. We have two of them. We have IPv4 noted like this and IPv6. The idea with IPv4 is that it has 32-bit IP addresses or 4-byte addresses. Hence, you see this notation 192.168.0.1. Each of these entities is 1 byte, and together they form 4-byte entities, which allows us to identify a machine. An entity complete like this, it's an IP address, and it allows us to identify a machine. Can somebody tell me on IPv6 how many bits do we have in an IP address? Now you can Google it fast. It's not like
6 parts.
6 parts composed of
4 bytes.
Just a hint. This number here, it doesn't have any link with the length of the address. So.
I know that it is in 16, in the 16 base.
128 bits.
Yes. Okay, so an IP address here. If I go here, it's 128 base. That's how many bytes? So that we stretch our brains a little bit here. One, 2, 8 bits. How many bytes?
Well, divide by 8. So
answering in.
16.
If you answer in written, I don't see it right away all the time because it's not blinking quite fast enough.
So it's 16 bits. Yeah.
Yeah, it's somebody told me 12. It's not 12. It's 16. Now, why did we have these two versions of the protocol? Is because more and more this number of bytes here, 4 bytes, it's not enough. I mean, we have so many devices connected to the network nowadays that this space here, represented on 32-bit, and I have a question for you. 32-bit. How many unique values can we represent in it?
Around 4 million.
Yeah, that is exactly 2 power 32. And it goes, normally if we take them as integers, from 0 to 2 power 32 minus 1. That's the number of values that we can represent on 32 bits. If we take 128 bits on the other side, we have as many as 2 power 28. Everyone is familiar with this? The number of bits in an entity gives you the power of those number of bits gives you the actual number of values that you can represent on a range of bits. Okay, so on 120 bits we have these many IP addresses as opposed to these many IP addresses. It's a lot more. It's with this range, you can actually represent, I think, or we can actually represent number of the molecule in the whole universe, something like that. As opposed to this one, which is around 4 million. Okay, which here, this one, which is not enough anymore. Why? Because we have at least one phone each of us. If you have a car, it has at least 1 or 2 IP addresses as well nowadays, the modern cars. If you have a washing machine nowadays, they have an IP address if they're connected to internet, and so on. Each device connected to internet has an IP address. Okay, that was the diversion about IPv4, IPv6. We won't be talking too much about IPv6 because it's a lot more complex as a protocol. It does a lot more things. If you need to understand how it works, if you understand IPv4, it will do well for IPv6 as well. Now, I have a question. Does the IP address of the host on which one process is running enough for identifying if I want to communicate? If I go back to the slide before, this one. Is this enough to allow this process here to communicate directly with this process here? Just the IP address?
We need to know the...
We also need the PID.
Yeah, that's a good remark. We need some additional information. That could be the PID of the process. So you have a unique PID for each process in each machine, and that will do well. In practice, the PID of the processes is not used because different operating systems have different ways of representing process IDs, PIDs. Some of them are using a single word or unsigned short 2 bytes for representing PIDs. Some others have a long integer in order to represent process identifiers and so on. So hence, or for that reason, the PID of the process is not used. In practice, because many processes can be run on a single host, there is a different information that is used here, and that information is called port. Did you hear about that?
Yeah.
Have you heard about it? For example, when you do what? When you do this www.google.com. Do you know if I'm going with this into the web browser, what port I'm attacking?
21 or 22?
80. Yes, and if you do this, it's 443. If you don't do this, it's 80. It's TCP port 80 or 443. So the port is an unsigned short usually. You don't need to write it. This is just we will meet with these things in practice. So it's a value on an unsigned short is represented usually on how many bytes?
4.
Not usually, no.
2 bytes. 2 bytes.
2 bytes, yeah. So an unsigned short is usually on 2 bytes. So it carries values between 0 and 4 to power 16 minus 1. Okay, so we need an IP address and a port. Together, the port identifies the process, I mean the socket created by that process, and the IP will identify the machine on which that process will be running. And with this information, it's like with the telephone number. You have the prefix and you have your phone number. 0744, it's a prefix which was allocated to Orange, for example, at the beginning. Then you have your phone number. You can think of it as being the IP address and the port number. Okay, and both together they uniquely identify you or the phone. This.
Can I ask a question?
Yeah, go ahead. If you just don't ask, just ask it.
What if I have 2 browsers running at the same time,
both requesting some HTTP protocol thing.
On the same server or on different servers?
I didn't think about that.
In fact, this port 80, it's allocated, is the process on the server side. The process on the server side uses by default port 80 for HTTP, so that any browser that wants to access, for example, google.com, be sure that it reaches the web server, not some other application. Okay, 80 is dedicated to web servers, 80 and 443. Now, if you go and attack yahoo.com, they will still, this one will be listening on port 80, this one will be listening on port 80. So whenever you create a socket on a given machine and you bind that socket to port 80, you're actually somehow telling the world, okay, I'm a web server. It's not necessarily mandatory. If you don't do that, others might think you're a web server and it will try to talk the web server language with you. And if you know how to answer, okay. If you don't know how to answer, the communication won't take place. It's like you're only speaking Japanese and only speaking English. Okay, we can try to talk to each other, but if you advertise yourself as being a talker, but we won't understand each other. Did I answer your question, or is not clear?
But I think I'm still not clear because, you know, I'm having the same IP. I'm listening to the same port. You said those are the two things that identify the communication. So how can you differentiate between?
Okay. Okay. So we have one machine here, and we have one machine here. You have an operating system here. And we have an operating system here. Whatever, it could be Linux, Windows, it can be different, it doesn't matter. You have a range of ports from 0 to 64K here, and a range of ports from 0 to 64K here. We will have 192, let's say 168.0.1 here, 192.168.0.2 here. Now, two different machines connected to a network cannot have the same IP address. Okay, the IP address uniquely identifies the machine. It's a unique relation with the machine. But you can have this machine having an application using port 80, and you can have this one using the port 80 as well. I mean, it's like you have two processes on these two different machines.
I think he was asking if we have, for example, Firefox and Chrome on the same computer. How does the port know to which of the browsers to send the information requested?
The browser is not using the port 80. It's just the server. Suppose this is the web server here, web. This one is using port 80. When you're actually creating a socket here on the client, on Chrome, and you're connecting to this machine on port 80, this local socket here won't be using the same port. I mean, the two applications should not, it's not mandatory to use this, I mean, they won't be using the same port. This one is the well-known port for HTTP, but as a client, I can allocate a random port, whatever, 62,000. And I'm using this as my local port identifier, but I'm connecting to port 80 if I want to connect to an HTTP service. Okay, all web servers will be using port 80 to be able to allow clients to connect to them. It's like port 80, it's well known. Everyone knows that it's web. And on the other side, it could be anything. It doesn't matter. Okay, so Chrome will be using 62,000. When you launch it once, it will be using 1,055 when you're actually opening another tab, and Firefox will be using a different port. It doesn't matter. On the client side, it doesn't matter because it's not the server who connects to the client. It's always the client that connects to the server. And once the connection is established, those things are learned by the other party. Did I answer your question or still not?
Yep. Clear.
Yeah.
Thank you.
Okay, so now you have some examples here of port numbers and well-known port numbers, 80 for HTTP, 25 for email, and so on. We will discuss about it. Now there are a few needs that a few things that you need to fulfill when you write an application. For example, first one is my application sensitive to data loss? What happens if some data is lost in transit? Well, if it's sensitive, then you need some sort of service from the transport services, from the networking. If it's not sensitive to data loss, then you need some other type of service. For example, when you're like now, when we are using right now, we're using audio and video. I'm transmitting you audio and video. This type of, I am telling you so that you know, this type of application, it's not sensitive to data loss. Why? Because if a small part of the data which encodes my voice is lost, you'll just hear some small gap. But if the protocol, it's actually trying to recover that data, what is happening is that, recover. The transmission protocols, there are two, TCP and UDP. TCP is able to actually reconstruct all the data that is lost, and UDP not. If you use TCP with audio and video, and TCP is trying to recover some small parts of data that are lost in transit, well, you'll have long gaps, the time required for TCP to hold until it gets the lost data, and whatever I'm talking right now maybe won't be reaching you until 30 seconds later, 1 minute later, and that's not acceptable. On the other side, when you're transferring file, well, you are sensitive to data loss. You don't want a piece of your file to be lost in transit. You want the data to arrive on the other side exactly as it was sent. Okay, so that is about data loss. Now, timing. There are some sorts of applications where timing is important. For example, the same example, we're talking over the phone. If you don't hear right away what I'm talking, it will be very difficult for us to talk to each other. When the network latency is very high, it's very difficult. We can try if you want to simulate a high latency network, and you will see that I'm talking. You won't be hearing anything for 30 seconds, so you'll talk at in turn. And exactly at that moment, the two signals would actually arrive at the other end, and both will hear what I am talking and what you're talking, and it'll be a mess. File exchange, it doesn't care. I mean, if it goes slowly, okay, we don't like it if it goes slowly, but on the other side, if it arrives on the other end in 30 seconds rather than in 1 minute rather than in 30 seconds, that's still okay. And bandwidth, how much effective amount of data per second we are trying to transfer. There are applications which are sensitive to that. There are applications which are, let's say, more elastic to that. And while covering this part, if we take these three dimensions, for example, file transfer, it's data loss sensitive. No, it doesn't. It doesn't accept loss. I mean, if it accepts loss, then your files won't transfer correctly. Is it bandwidth elastic? Yes, it is, because we don't care if it transfers in 1 hour or in 5 hours. It will still do the job. Is it time sensitive? No. These two things are kind of interrelated. This is amount of data per second. This is the actual timing between messages. How fast? I mean, how should I put this? In what timely manner this is happening? Is the time an exact clock? I mean, things are happening at an exact rate or not? Email, it's sensitive to data loss. Yes, it doesn't allow. Is it elastic? I don't care if it arrives today or tomorrow. Time sensitive, no. And on the other side, everything dealing with real-time audio, video, stored audio, video, interactive games, games more than the others, because whenever you move your mouse and move your character in the game, you want that to be reflected on the other side or on the other players right away. So you need nowadays even tenths of milliseconds. It needs to be that fast. Is it loss tolerant? Yes. If you lose a position within your character's movement, it's not that bad. I mean, it impacts the quality of your game, yes. What you perceive as a fluid movement of your character, yes, but it doesn't allow you to shoot the other guy. Okay, and in bandwidth, it doesn't require that much. A few kilobytes and up, it's enough for that. So these are some kind of examples of what or how these dimensions are reflected into the actual type of services needed for these types of applications. And now we have in TCP, and we will be working with two types of protocol, TCP and UDP. Both are part of the we are calling the TCP IP protocol. It contains both of them. This one and this one. They both are parts of TCP IP. Now, one offers connection-oriented. It means you need to set up a connection communicating between entities. This one, it also offers reliable transport. That means whatever you send from one side, it arrives on the other side, or if it's not able, or if data doesn't arrive because the actual physical path is not there, then the other party knows. Okay, and both the sender and the receiver know. It also offers flow control. This is a thing that we will talk about a little bit later. It offers also congestion control. That means this is a protocol that will never actually flood your network beyond its capacity. It has knowledge inside that allows it not to flood the network. What it does not provide timing and a minimum bandwidth guarantee. But TCP, one-in-one, is a connection-oriented, reliable transport. Data is not lost. UDP, on the other side, it's unreliable. I mean, whatever you send, it might get on the other side or it might not get there. More than that, you're not notified. Neither the source nor the destination know if data has arrived. It does not include any connection. You don't need to set up any connection. Okay. When handling UDP, it doesn't offer reliability. It doesn't offer flow control. It doesn't offer congestion control, timing, or bandwidth guarantee. Well, the question is, why would we use such a protocol? Because it's usable when, for example, streaming something where I don't care if some data is lost. And because it doesn't provide all of these services, usually it's a lot more faster. Implementing any of these things comes with a cost. Flow control, congestion control, reliable transport comes with a cost. Usually you lose in bandwidth, you lose in speed, you lose in all the other things that you might look for. Okay, let's keep this part and network programming, because I want to actually show you an example if I can. From the networking programming point of view, there is an API related to sockets. The socket API, it was introduced, I will skip the history, in 1981, whatever, in Linux. Linux was the first operating system implementing networking. And it introduced two types of transport service at the time, namely TCP and UDP, two types of sockets. They were actually represented at the operating system layer as two types of sockets. This one, UDP, this one, TCP. And we will see how that translates in programming. Let's to this part. And whenever we're implementing the TCP application, or pairs of applications, the client and the server, usually we have a client that will contact the server. The server process must be running in order to, must be listening on a socket in order for the communication to be able to take place, the connection to take place. Okay, so the server should have already a created socket, and the client contacts a server by creating a local TCP socket. It specifies the identification data that we talked about, IP address and port of the server. So you see that the client should know in advance these things, both the IP and the port on which the server is running. That's why, I mean, the IP addresses can be discovered in some way, or when you implement your application, you know that the server will be running on whatever, www.google.com. But the port, either it's predefined and it's well known, or you actually make you take a decision that you use port 2000 for your applications. And then you create a connection with the server. When contacted by a client, a server, so what is happening, this is quite interesting. The server listens on a socket which it initially creates, but in order to allow a server to serve multiple clients, that socket cannot be used for communication. It's only used as a rendezvous point. Okay, so we have, if I meant to, I have a process here, I'll draw it like this. So the process, it has an initial socket rendezvous, I'll call it. And we have processes on different machines. Whenever I have a client connecting, it will access the rendezvous socket. And what happens exactly at that time is that the socket, the server process splits out a new socket, which will actually be used to handle the communication. I will draw it as a tube here, where data will go both ways, as an actual socket for communicating with that remote process. Client 1, client 2, client 3. Why is TCP implemented this way? Well, it's implemented this way to allow multiple clients to actually talk to the same server. Okay? For each one of them, you'll have a different socket, and the actual virtual communication will go over with that socket. The original rendezvous socket will only stay on for meeting between the client and the server, and it won't serve to any other purpose. We will see in programming how that actually maps into practice. I will show you this into an example. What is actually now the actual calls that we need to do on a server. Whenever we create a server application, and I will just spend 2 minutes more with you. In a server, the first thing you call, the underlying things are the actual API calls without the parameters, which are not shown here. So the first thing, you create a socket. Then, and importantly, on a server, you need to actually assign a well-known port. Whenever you create a socket, that socket is created with a random port assigned to it. Any random number which is not used on that machine between 0 and 65,545 and 35, sorry. If you call bind, you can specify a specific port number that you need to be assigned to that socket. If that port number is not already used by another application, by another process, then it will be assigned to you, and that socket will be bound to that port. Then it's there is a third call, listen. I will explain what listen does a little bit later. You can actually skip this call if you want, but in practice it's useful. When you've done this, you have a socket. Now, in order to actually actively listen for incoming connection, you need this accept call. Now, this accept call goes dormant until there is a client that comes in and tries to connect to the server. And whenever it does that, it returns a new socket. The socket that will be used by the server to communicate with that client. And then, from this point on, we have a connection. On the client side, what we do in parallel is we need to create a socket with a socket call, and we don't need to do anything else than call connect. And in the connect call, we specify an IP address and a port. When the connect returns, you have either a successful connection and a two-way communication path between the two processes, or an error if the connection was not possible. Okay, the connection, TCP connection setup takes place in between those two calls, connect and accept. And then when those are fast, then you can actually write and read data either with the write and read system calls that like you did in the operating systems, or with send and receive that are specific to sockets. Okay, these are the APIs that you need to use. You get information about this in the man pages on Linux or on MSDN for Windows. And I will show you the example during the lab because I don't want to waste all your break. I have an example here. It's a C application. The server is here with all it includes files that are needed. I predefined a port file 1500 for my example here. What my example does, it creates a socket, it binds it to the server port, and then it accepts a connection in a indefinite while loop. It handles the errors, it reads a message from the socket, and it writes back to the client exactly the same thing. It's an echo server. Whatever you send to it, it bounces back to you. It's a very simple teaching-like example. Now, my last part here in the server, usually because it's in a while one loop, never happens, but usually by the end, you close the socket. Yeah, it's happening. It answers and it closes the connection, but the rendezvous socket is never closed here in my example because the server sits there and waits indefinitely. The client side, it creates a socket here. I will explain during the lab what get closed by name does. It creates a socket, it connects to the server, it writes to the server whatever you give it as the first argument in the command line, a string, and it reads back a message from server, and that message will be exactly what the client sent. And it displays that on the standard output, it follows the socket. So this is the simplest example of a TCP program client server that you might have. And with that, I'm done. Sorry for wasting 4 minutes from your break. If you have any questions, feel free to ask them. If not, I'll meet you during the lab and we can discuss over it. And I will show you what the first assignment for the lab is during the lab.
So this works exactly like FIFOs or pipes or anything?
Exactly, it's the same mechanism. Every inter-process communication, it's based on the same principle. You need to set up something and you communicate and then you tear it out.
Okay.
Now, this is the simplest thing that we might develop. Is if you want the hello world in C++. Okay, we cannot do anything simpler. We will start from the next lecture and from the next lab, handling with data representations, how is data represented, how we exchange data between two machines. What happens if I send a string to another machine? What happens if I send an integer, for example, or a float number for that matter? How they are represented in two different, for example, operating system architectures. Is an integer on, and here we are going to talk about big endian Little Endian. Does it ring a bell?
Yep.
Yeah, ASC, yeah.
Yeah, the PTSD from ASC.
Yeah, exactly. So we will talk about a little bit here about that, and you will see how that actually mirrors into practice. But we will discuss that next lecture and during the lab. Okay? Thank you guys for being here, and I forgot to record this. Don't remind me to record the next.
It's recorded already. Someone else.
Somebody started the recording.
Okay, that's a very good thing.
Can you please save it here on Teams?
Yeah,
it will be saved.
Normally you will see it here in Steam. It's on streams in Teams. I mean, in Teams, in your Microsoft account, it will be visible, but I will take my time and process it. Not sure today, and I'll put it on YouTube in a channel as well, so that you have the entire class a little bit edited with all the stuff that is not needed taken out.
Nice.
Okay, I will set up a YouTube channel for that, and I will publish it here. The raw material, if you go into Microsoft Streams with your account, you will see it already.
Okay.